chapter let's look at your chapter 5. So we have done with your chapter 1, 2, 3, then so we will start looking at chapter 5 and 6. Chapter 5 and 6 will be more difficult compared to your 1, 2, 3, 4. Okay, so then we will spend more time on your chapter 5 and 6. Okay. So now, chapter 5 is on discrete distribution. So we look at the first word, which is a random variable. So a random variable is defined as a variable whose value is determined by the outcome of a random experiment, and normally we use a capital letter X. Capital letter, not small letter. Capital letter is the random variable. Small letter is the observed value. Okay, so now, when you do an experiment, remember when you do an experiment, when you flip a coin, you may get head or tail. So you may get head or tail. Am I right? Okay. But when we try to put under discrete distributions or random variable, then we cannot accept head or tail. Then how can we do that? How can my X be? If I flip a coin, what random variable can I have? When you flip a coin, you have head or tail, right? So what random variable that I could make? Two possible X. So one is the number of head obtained. When I flip this one time, how many heads I could get? If I flip coin once, how many heads I could get? Sorry? What's the number? 1. Can I get 0? Why not 0? When I get a tail, I get what? My X is 0. Because my X is the number of heads. So X is number of heads. But I do it once only. So my X can take 0 or 1. So I still can have more than one number. Right? That's why I say I can have two possible X. So I can also have the second possibility, or the possible random variable is number of tails. And my number of tails is also 0 or 1. Okay? So this is how we get the random variable. Okay? So now, if I roll a die, when I roll a die, so what is the X could be? A lot, right? When I toss a coin, then it's only the number of heads or number of tails. But when I roll a die, I say I have a lot, many possibility. So, one example. What is my x if I roll it down? So what is the possible x? Oh, roll it down a bit difficult. Very straightforward is what? Very straightforward is the number appear, right? What is the number appear? So what is the number appear? It could be 1, 2, 3, 4, 5, 6. When I do roll one die only, not many, sorry. The one with a lot is when I roll 2 dice or roll it down twice or 3 times and so on. Okay? So why 2 times a lot? I can have some of the 2 number appear, right? Number of times 6 appear, or number of times even number appear. Okay? So that's why this is random variable. Random variable, then we can have the value. How can I know the number, the answer? It's from the outcome for a random experiment. Okay? Then we have discrete random variable. So I have a random variable that assumes countable value, that is called a discrete random variable. Then example is number of cars sold at a dealer's shop during a given month. Okay? The number of houses in a certain block. The number of heads obtained in 3 tosses of a coin. Okay? And besides discrete, we could have continuous. Continuous is a random variable that can assume any value contained in 1 or more intervals. That we call this a continuous random variable. Okay? Now, the height of a person is one of the examples. The time taken to complete an exam, the weight of a baby, the price of a house. All these are examples for continuous random variable. Okay? Now, all these you think is discrete or continuous? Discrete, right? Discrete, right? Okay, so now, then we look at probability distribution of discrete random variable 5.2. Then, what is the probability function of a discrete random variable? So, the probability that the discrete random variable x takes, we call this a P probability of x equals to x, small letter x. Is defined as the sum of the probability of all sample points in S that are assigned the value x. So we will sometimes use probability of x equals to x or Px. And Px is called the probability mass function, PMF. When this is discrete, we can use PMF. Okay, continuous, we don't do that. We call something else. But sometimes we can also call this a PDF. Okay? So now, probability distribution of a discrete random variable can be represented by a formula. You give a formula, you can give a table or a graph. Okay, the two characteristics is that one, the probability must take value from 0 to 1. Then sum of the probability must be 1 for all possible values. Okay? So now, example 5.1. The following table lists the probability distribution on the number of breakdowns per week for a machine based on past data. So number of breakdowns, I have 0, 1, 2, 3. So now, these are the probability, the corresponding probability. A, can you present the probability distribution graphically? So, if you want to do it graphically, we do line graph. We do line graph. But this line graph could be a little bit different from what you think. Okay? So, we are to show the probability distribution, that means this table. So I must first let X. Okay, so it is very important in these two chapters you let X be the correct thing. So I will let X be the number of breakdowns for this machine in a week. Okay, now I want to present this in a graph form, is a line graph. So my y-axis must be my probability of X equals to X. Okay? But the maximum is 0.35, so I have 0.35, 0.3, 0.25, 0.2, 0.15, then 1, 0.05, and 0. Okay, so when this is 0, I don't need to have my 0 on the axis. Then I can't see the graph. So when this is 0, the probability is 1. We call this a line graph because we don't draw a bar. We draw a straight line. Normally we have a line graph. You can have as a bar graph also, but please don't join them. There must be a gap in between. Okay? So now, when this is 1, then we have 0.2. Then 2, you have 0.35. Then 3, you have 0.3. And this is my X. Okay. So now B. Find the probability that during a given week, the number of breakdown for this machine is exactly 2. So B, number 1. I want to find exactly 2. What is exactly 2? It's just equal to 2, right? So you need to put it as probability of X equals to 2. X equals to 2 is, probability is, so we have 0.35. Alright? Then what about 2? 2 is from 0 to 2. 0 to 2, 0 to 2 is including 0 and 2, right? So I have equals to 0 to 2. This is from 0 to 2 with equal sign. Okay? 0 to 2 is the one with equal sign. 0 to 2 is X equals 0. plus x equals to 1 plus x equals to 2. So x equals 0 is 0.15, 1 is 0.2, right? The probability is 0.2, and 0.2 we have 0.35. So altogether we have 0.7. Okay? Now, then what about more than 1? Number 3, more than 1. More than 1 with equal sign or not? No, right? So not equal, so more than 1 we have 2 or 3, right? Okay, 2 we have 0.35, 3 we have 0.3, so we have 0.65. Then what about at most 1? At most 1 is less than equals to 1. So less than equals to 1, that is 0 and 1. 0, we have 0.15, 1 we have 0.2. So we have 0.35. Okay? So now, so example 5.3. According to a survey, 60% of all students at a large university suffer from math anxiety. Right? 2 students are randomly selected from this university, and X denote the number of students in this sample who suffer from math anxiety. So can we find the probability distribution of X? So when we are to find the probability distribution, then actually it's only the X and the probability of X. Now, your X can take what value? I have two students are randomly selected. How many students are actually have this problem? X can take what value? 0, 1, or 2, right? So then I have 0, 1, or 2. So how can, sorry, I define N as the event that the student selected does not suffer from math anxiety. N is for no. M is for that, yes, the student suffer from math anxiety. So now, how can I have a 0? What are the events? What are the events? NN. Can I put NN like that? No, because event need to be in set form, right? Event need to be in set form. Okay, how can I have this probability? I have 60% of the students has this problem. So probability of M is, okay, then what about probability of N? Okay, so what about NN? 0.4 times 0.4, so that is 0.16. Alright, then how can I have 1? How can my X be 1? NN or MN, right? So NM is 0.4 times 0.6 and MN is 0.6 times 0.4. So end up with what number? 0.48, right? Okay, 0.48. Then how can I get a 2? 2 is mm. So mm is 0.6 times 0.6. So that is 0.36. So when I sum this, I get, what I get? 1. I need to get 1, huh? Okay, so now, after we know the distribution, then we can find the expected value. So expected value of a random variable or a function of a random variable. That means we are looking for expected value of a random variable, so that is EX. I can also have a expected value of function or random variable, so I can also look for EGX. Okay? So if X is a discrete random variable with probability function Px, then the expected value Ex is sum of X multiplied with Px. Generally, Ex is a population mean mu. Okay? So you need to remember the expected value normally, or we will have it as the mean mu. Okay? Then now, if X is a random variable, discrete random variable, then I have a Gx, a function of X, then expected value of EGX is sum of Gx times Px. Now, example, later we have Ex squared. Ex squared. So my Gx is an X squared. Then also remember, if C is a constant, expected value of C is C. Any number. Then expected value of CGX, a number multiplied with a function that you can pick up. Okay? So you will have more than one function. Okay, E of G1x plus G2x up to GKX, then you can find the expected value of them one by one. Okay? I don't think 1 hour class needs to go out, right? Now remember, sum of Px, sum all the x is 1. Okay? So, if I sum x multiplied with Px, then I call this an Ex. Okay, so now when we have E of C, so that means you sum C with multiply with PX. Because according to this, as long as anything, you just put it in. Okay? So when you have a sum, then you can take out the C, right? But sum of PX is 1, so this is 1, so that's why I have a C. Okay? Then just now also we say E of GX is a summation of GX multiplied with PX. So that means if I have to find EX squared, then I sum X squared multiplied with PX. So if I want to find E of X squared plus X, then how do we do it? Then according to the last one here, if you have a function with a plus, then what you can do is you can do this separately. That grant this happen. So I can do it as E of X squared plus EX. That's what it means for the last one. Okay? So now, if that's the case, if I have EX plus 1, then this is just EX plus what? What is E? I'm supposed to have E1, right? But what's E1? EC is C, right? So then this is just EX plus 1. Okay? So now, it becomes quite straightforward, you see. If I don't want to do this, I can do what? If I don't want to have this, my EX squared, I can do it as sum of X squared plus X multiplied with PX. Right? Like this one also, I can do sum of X plus 1 multiplied with PX. So then this becomes X times PX plus PX, right? Then when I put the sum in, I get sum of X PX plus sum of PX. Isn't it? I get back this. Okay? Okay, huh? This thing we will repeat again and again later. I mean, not only plot and set 1. Plot and set 1 is always the starting point. Then definitely you will have plot and set 2. Then plot and set 2 is a starting point for all the statistics related subject. No matter you're AM, AS or FM, definitely you will do statistics related subject. Like you will do max state, you will do predictive modeling, you will do what? Simulation. Who else? Long is what? I don't remember. Non-parametric, and we have a lot of we have many statistics subjects. Then we will repeat the same thing, but we won't go through so detailed anymore. we need to assume you know already from 1 and 1. You get what I mean? Just like after you know how to plus 1 in your standard 1, then your teacher teach you x plus 1 the time, then will not teach you 1 plus 1 again, right? Okay, so hopefully you understand that. Okay. So now one more, the general thing is this. What's the variance? We know EX is always the mean. EX is always the mean. So what's the variance? Variance, as you know, is a sigma square, but actually this is expected value of x minus mu square. This is by definition. Expected value of x minus mu square, alright? Okay, so now this is by definition. Okay, now mathematics always have by definition. That means somebody decide and define this. We call this define. We define this thing already. Okay, but when you want to count this, then it could be more difficult. Then we have a computational wise. Alright, then you may wonder, how come this is e of x squared minus mu squared? Right? How come this becomes e of x squared minus mu squared? Because what is x minus mu squared? X minus a minus b squared, what do you get? Just like that, right? Is x minus mu squared, what do you get? X squared minus, I put 2 mu x, then plus mu squared. Okay, then just now we know already, right? We say you can go in, then we go in e x squared minus e 2 mu x plus e mu squared. Right? But now, ex squared can do nothing. But just now we already say also when you have a number, you can take out, right? So 2 mu is a number. So I have minus 2 mu ex, right? Then e of mu square is a number. So I have plus mu square. So if that's the case, what happens next? What happens next? E of x squared no change, but 2 mu multiply with ex is the mu, right? Ex is the mu. So then I have minus 2 mu squared plus mu squared. So I have e of x squared minus mu squared. I personally my habit always let the student know later on when you find out, I always write like that, e of x squared minus ex and then take a square. Because mu is ex. Okay? So anyway, this is the variance. This is the variance, Okay, then we go back. Now we do one example. This was the probability distribution that we have, right? So now, this is the distribution we have in example 5.1. Can we find the mean and standard deviation for the number of breakdowns? Mean is ex, right? So EX is given by sum of X times PX. Alright? So my 0 times this is 0. 1 times this is 0.2. 2 times 0.35 is 0.7. 3 times 0.3 is 0.9. I sum this, I get 1. So when I sum this, I get 1.8. So I have this mean as 1.8. Okay, then x, why I want to find x squared px? Because I need to find standard deviation, right? To find standard deviation, the first thing I must find ex squared. Ex squared is sum of x squared px. So sum of x squared px, 0.5 times 0 square, I have 0. 0.2 times 1 square, I have 0.2 also. Then this is 0.2 square times 0.35, so it's 0.7 times 2 is 1.4. Then this is 0.9 times 3, this is 2.7. Correct, so when I sum, I have 4.3. So then this is 4.3. Okay? Then I can then find variance of x, right? Variance of x is e of x squared minus ex and take a square. So I have 4.3 minus 1.8 squared. So that is that's what? So what do you get? So 1.06, but my question is standard deviation. Standard deviation is the one with a square root, right? So I get 1.09. .296. Don't need to round. Okay. I want to remind you all that coming Monday is your